Today's notes are on 2.4a, writing equations of quadratics given graphs. So before we begin, let's do a quick review of the three forms of quadratic functions. And that'll be y equals ax minus h squared plus k. Standard form is y equals ax squared plus bx plus c. And intercept form is, y equals a x minus p x minus q. Now keep in mind, what we're given will determine which form we can write in, right? So in vertex form, we are given the vertex. In intercept form, we need to remember that it's not just an intercept, it's the x-intercepts. Okay, and in standard form, we only know the y-intercept, which is c. Okay, so this helps us figure out how we can start to write equations given a graph, right? So we're moving backwards now. Up until now, I've given you the equation and you've written or you've graphed the function. So now we can go backwards, and if I give you a function or a graph of a function, you should be able to write an equation. Now there are two things you need to find. You need to find the important information, like the vertex, the x-intercept, the y-intercept, but you also need to find y. Okay, so I'm going to say you need, you also need to find a. So you need, number one, the easy critical point. Right, and so that's the vertex or the x-intercept, and then you need to identify a and put that into your equation. So these are the two things you need to do. So first off, if I'm writing vertex form, this is my vertex. So I'm going to write vertex is 1, negative 4. And so that means we're going to plug in for, let's do this in, I'll do this one in red, h and k. Okay, so that means my vertex form is y equals, and my a value, hopefully you guys remember, it's your first slope right here. Okay, so this is up 1 over 1. So my a is 1. Okay, so first slope. Let me write that on the side here. A equals first slope, rise over run. For us, it was 1 over 1, which is just 1. And so then we have x minus, and that h is always going to change signs, so the positive one becomes a negative one, squared minus 4. And we're done. Okay. So let's do a second one, just to continue. We'll do 3 vertex forms, and then we'll do 3 intercept forms, and then you guys can practice. So this next one, we know that a is negative because it's going down. So it's starting from here to here. We're going down 1, positive 1. So negative 1 over positive 1 is just negative 1. So we have y equals negative 1. And my vertex is at, let's see, negative 2 and positive 4. So I'll have x plus 2, because we switched the sign, and then plus 4. So far so good? So hopefully this last one you're like, okay, well I could do this, right? Ready? This is my vertex at 3, negative 2. My a value this time is up 2, it's plus 2, over 1. Right? So notice it has to be over 1. So my vertex form is y equals 2 parentheses x minus 3, because a positive changes to a negative. Don't forget the squared, minus 2. Here I'll write a equals 2 over 1, which is 2. Okay, so now let's go into intercept form. It's the same idea, it's just a different form, right? So you need the easy critical points. So for us, this is my x-intercept. And that point is let's not even write it as an ordered pair. I just need the x-intercept, and I know that's at 3. And then this x-intercept is at -1. Now, do remember that when you put numbers into parentheses, you're always going to change the signs. So I know my a value always goes first. Right now, we found that earlier, and it was 1. And then I'm going to go x plus 1 and x minus 3. Okay, so any number inside changes the signs, inside parentheses. Maybe I should write that at the top. Any number inside the parentheses changes signs. And it changes when we describe the transformations, and it also changes when we write equations. So let's go up now. My intercept form here, this is 0. And this is -4. So it'll be y equals negative. I'm going to skip the 1 because you don't have to write it. And then x minus 4. Actually, let's write it in and I'll show you how simplified it can be. And then we'll do x minus 0. No, not x minus 4, x plus 4. Okay. Now, this has a lot of extra numbers. This can also be written as, y equals negative x without the 0, and then x minus plus 4. Okay, so I would take either of these. So that's horribly written. This one you might see on like a test if I wanted to try to confuse you. Okay, so it could be written without the 1s and without the 0s. So the last one, hopefully this is like, okay, I can do this. My x-intercept here is 4. And this one is at 2. So it'll be x minus 2 and x minus 4. Okay? Take a moment, try 1, 2, and 3 for vertex form and intercept form. And I'll pause here to write in the notes. Okay, so let's do a quick run through. This is down 1 over 1 for our slope. This one is down 2 over 1, so that's -2. This one is up 1 over 1, which is 1. So those are the numbers I put in for all the forms, right? This one is invisible, so I didn't write it just to show you how it could look. The vertex is up at the top. Switch your signs, -3 to +3, -1 to +1, and 0 doesn't have to show up. So I wanted to show you that this is also technically vertex form. Okay, it doesn't look like it because there's no parentheses, but it's just shifted down 1, like a translation down 1. Okay. Here are the x-intercepts. Please make sure to switch both of the signs, so the -5 and -1 become +5, +1. Okay, and again, you don't have to write the 0, so we sometimes put that in front. It doesn't matter which number you write first for intercept form, okay, because 5 times 1 is the same as 1 times 5. And then last one is +1 and -1. So then the question is, how do you get standard form? Well, we know A. You can find A using the first slope. Okay. And we know C equals the y-intercept. But then the question is, we need to find B. Okay. So then there's 2 ways that you can solve for B. Okay, and I'm just going to show you guys these 2, and then we will go from there. Let's see. Let's use this one. Okay, so let's say we're given number 1. Is that the one I want to use? No, let's do example 3. And we're going to find standard form of example 3. Okay, so let me, excuse me, show you 2 ways. The first way is that you can actually take your equation and distribute, which is the same as multiply, vertex or intercept form. I recommend doing intercept form. It's a little bit easier. Okay, so let me copy down this equation. Y equals 2 parentheses x minus 2, x minus 4. So what you're going to do now is what we used to call FOIL, right? So you're going to distribute and you say x times x. Let me do it in a different color. X times x is x squared. X times negative 4 is negative 4x. Negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. Now there is a 2 in front, so I'm going to bring that down. And what you're going to do is distribute to everything, but we're also going to combine. Okay? So now I can do 2 times x squared, that's 2x squared. Negative 4 minus 2 is negative 6, and I'm going to multiply 2 times negative 6. So that'll be negative 12x, and then 2 times 8. Sorry, this is a horrible space. I should have given you more. I apologize. So 2 times 8 is 16. And so this is our standard form equation. Okay. Now, if that was a little bit much for you, what you could try instead is solve for b. Okay. Use x equals negative b over 2a and solve for b. Because we know x, that's my vertex. So that's my h of the vertex. We know that a is the first slope. Okay, so let's go back up and we'll see that in this form, the x of our vertex is 3. So we're going to set up 3 equals negative b, which we don't know, right? But we do know that a in this problem was 2. So now you have one variable left and we can solve for b. So let's see. I can simplify 2 times 2, so that's 3 equals negative b over 4. I'm going to multiply by 4 on both sides. Okay. And that gives me 12 equals negative b. And then I need to divide by negative 1. And I get b equals negative 12. And you guys see how once you have b equals negative 12, you can write your a, b, c formula based on this. Now, this one did not work so well. Like if I didn't see this, do you see how like I have a, which is 2, and I have b, but if we look at our graph, we don't have a y-intercept, right? So in this case, distributing is much faster. Otherwise, now we'd have to, let me write that in red. If you can't see it from the graph, you have to plug in y-intercept equals, plug in x equals 0. Not y-intercept equals. So for the y-intercept, you'd have to plug in x equals 0 to find c, to give me c. Okay, so this works sometimes, but this always works. Okay, hopefully that helps if you missed today's class or needed a little bit extra help.